Let's talk about evaluating integrals using substitution. What is the antiderivative of 3 cosine 3x? You might think that it's 3 sine 3x plus c, but that is not the case, and I can show you. By the chain rule, the derivative of 3 sine 3x plus c is going to be 3 times 3 cosine 3x, because when you take the derivative, by the chain rule, the 3 pops out front, and so now you have 3 times 3 cosine 3x, which is 9 cosine 3x, not 3 cosine 3x. So the antiderivative of 3 cosine 3x is not 3 sine 3x plus c, because when we take the derivative of this, we don't end up with this. We can find the antiderivative. By the chain rule, the derivative of f of g of x is f prime of g of x times g prime of x. Thus, the antiderivative of f prime of g of x, g prime of x dx is f of g of x plus c. This rule is awkward. Instead, we use an equivalent technique called substitution. We use substitution when we want to integrate a trig function of some other function, like 3 cosine 3x, or sine 10x plus 2, or x cubed secant squared x to the fourth. So again, we're integrating a trig function of some other function. Here's the way substitution works. I'll go over this. It won't make any sense to you, but you'll see how we use it. Let u be the function in parentheses, the arguments of the trig function, that is the thing we're taking the trig function of. We change the integral from 1 in terms of x and dx to 1 in terms of u and du. We integrate the new integral, the one that's in terms of u and du, and then we switch back to x. So let's look at the example we saw a moment ago. Find the integral of 3 cosine 3x, the antiderivative. Okay, again, we let u be the function in parentheses, the arguments of the trig function, the thing we're taking the trig function of, namely 3x. So u is 3x. Now let's find du. Okay, here's how we find du. If u is 3x, then du dx is just 3. It's the derivative. If you multiply both sides by dx, and I know that seems cheesy, but it works, it's legit. If you multiply both sides by dx, you end up with du equals 3 dx. That is du. du is 3 dx. So see this 3 dx over here, or we could do it over here, 3 dx? That is du. So now when we rewrite this in terms of u, what I've just circled here, 3 dx, is our du, and then cosine 3x, okay, since 3x is u, cosine 3x is cosine u. You're probably not going to understand this the first time through, but that's okay. We're going to go over numerous examples. So now we have the integral of cosine u du. The antiderivative is just sine u plus c, but u is 3x. So this is sine 3x plus c. Let's check. The derivative of sine 3x plus c by the chain rule is going to be 3 cosine 3x. So sine 3x plus c is indeed the antiderivative of 3 cosine 3x. Find sine of 10x plus 2. Okay, again, let u be the function in parentheses, the arguments of the trig function, the thing we're taking the trig function of, that would be u equals 10x plus 2. Let's find du. Du dx, so here's how we find du. Du dx is 10. We're going to skip this middle step in the future. We'll just jump straight from here to here. So u is 10x plus 2, means du dx is 10. Multiply both sides by x, dx, and we get du equals 10 dx. Okay, so we have u equals 10x plus 2, du equals 10 dx. Oh, but wait! We don't have a 10 dx. We just have a dx. But we can multiply the inside of an integral by a constant and the outside of the integral by the reciprocal of that constant. So it's legitimate to multiply the inside by 10 and the outside by 1/10. Don't try that with variables like x. Not okay. You can't do that, but you can do it with a constant. Okay, so now we have 1/10, 10 sine 10x plus 2. So we change the integral from 1 in terms of x and dx to 1 in terms of u and du. And again, we saw earlier that u is 10x plus 2 and du is 10 dx. So this stuff, that stuff's just du. And then this, sine 10x plus 2, that's just going to be sine u. So we have 1/10 sine u du. Again, what I've circled here is du, and this thing is sine u. Okay, 1/10 sine u du. The antiderivative of this, so now we integrate the integral and we switch back to x. Okay, the integral is going to be negative 1/10 cosine u plus c. Switch back to x and we get negative 1/10 cosine 10x plus 2 plus c. And we check, if we take the derivative of this, we end up with sine 10x plus 2. So this is indeed the antiderivative of sine 10x plus 2. Find x squared cosine x cubed dx. Okay, so we're going to let u equal x cubed. Then du is 3x squared dx. We don't have a 3x squared dx, so we need to multiply the inside by 3 and the outside by a third. And when we do that, we get, okay, this stuff is going to be our du, so we've got cosine u du, 1/3 cosine u du. The antiderivative is going to be 1/3 sine u plus c, which in other words is 1/3 sine x cubed plus c. Find the integral of 7x cubed secant squared x to the 4th. Again, you can probably figure out what u is going to be. U is x to the 4th. That's what we're taking the trig function of. Du is 4x cubed dx. We don't have 4x cubed, so here's what we're going to do. You can move the 7 to the outside. It's legit. So we end up with 7 on the outside. We have x cubed secant squared of x to the 4th. Now let's multiply the inside by 4 and the outside by a 4th. And this is what we end up with. So 7/4 4x cubed secant squared x to the 4th dx. What I've circled here is du. So it's going to be our du. And this is just going to be secant squared u. The integral of secant squared u, the antiderivative, is tangent u. So we get 7/4 tangent u plus c. In other words, 7/4 tangent of x to the 4th plus c. How about this one? Find the integral of 2x, x squared plus 1 cubed. Okay, we have not seen how to integrate something like this before. No trig functions here. But we also use substitution when we want to integrate a function raised to a power, like 2x, x squared plus 1 cubed, or 7x minus 1 to the 10th. Or how about sine x raised to the 5th times cosine x? So we would use substitution in each of these cases. Here's how it works. We let u be the function we're raising to a power. Find du. We change the integral from 1 in terms of x and dx into 1 in terms of u and du. We integrate the integral, and we switch back to x. So here we have 2x, x squared plus 1 cubed dx. Okay, u is the function we're raising to a power, so in this case it's x squared plus 1. Not x squared plus 1 cubed, just plain x squared plus 1. Du is then going to be 2x dx, which we have. So what I've circled here is du, and so when we rewrite this in terms of u, this is going to be our u cubed, and what I've circled is du. So we have u cubed du. The antiderivative of that is u to the 4th over 4 plus c, which in other words is x squared plus 1 to the 4th over 4 plus c. Lastly, let's do this one. Find the integral of e to the 4x square root 1 plus e to the 4x dx. Okay, we're going to rewrite 1 square root of 1 plus e to the 4x as 1 plus e to the 4x to the 1/2. Okay? And recall that, so again, this is the function we're raising to a power, 1/2, so we're going to let u equal that. U equals 1 plus e to the 4x. Recall that the derivative of e to the x is e to the x. E to the x is its own derivative. And the derivative of e to the h of x is h prime of x, e to the h of x. In other words, it's just h prime, e to the h of x times the derivative of the exponent. So in this case, the derivative of 1 plus e to the 4x will be, well, the derivative of 1 is 0, and the derivative of e to the 4x is e to the 4x times the derivative of the exponent, namely 4. So du is 4 e to the 4x dx. Okay, we don't have a 4 e to the 4x dx, so what we can do is multiply the inside by 4 and the outside by 1/4, like we do over here. So now we have 1/4 integral e to the 4 e to the 4x, 1 plus e to the 4x to the 1/2 dx. When we make the substitution, let's see, 4 e to the 4x dx, that's our du, and u is 1 plus e to the 4x, so this is just going to be 1/4 u to the 1/2 du. 1/4 u to the 1/2 du. The antiderivative of u to the 1/2 is u to the 3/2 over 3/2 plus c. So we have 1/4. Dividing by 3/2 is the same thing as multiplying by 2/3. So we have 1/4 times 2/3 u to the 3/2 plus c. 1/4 times 2/3 is 1/6. So we end up with 1/6, 1 plus e to the 4x to the 3/2 plus c.